Hi everyone. Happy Wednesday. Thank you for joining me today. Yeah, we're going to get started because we're playing with particles today and we're going to make them jump. So, yeah, it's comfortable here in California and I think we shan't dally much longer. We're just going to jump right into things. Last week I played with PixiJS, which is a snazzy little web graphics library that kind of has a 2D API, but actually uses WebGL under the hood, so you get all kinds of nice effects where you can get a nice smooth frame rate and all kinds of extra stuff that's kind of tricky to do in Canvas, but not that hard to do in WebGL, and provides a kind of pretty friendly API on top of that. So one of the things that I think I love about PixiJS is because it can handle so many objects at the same time, it makes it possible to do things like particle effects. I love particle effects. I think they make games, they make interactivity really, really rad. So I want to play with making particle effects using PixiJS today.Maybe we'll try fire, smoke, confetti, fireworks, who knows? Definitely fireworks. But yeah, that's the goal. So we're going to do things a little differently this week, however. Normally, I jump right into the glitch editor. You can see I have a glitch editor here, and actually I have a project prepared that I'm going to walk us through, sort of the frame of a project for particle effects. As opposed to me editing here today, I want to show off something new that launched this week on Glitch, and that is, let me bump up my screen size, a glitch extension for Visual Studio Code. This is super cool because what this means is that as opposed to having to use the in-browser editor, which I personally really like, you can also connect to Glitch and do live code editing in Visual Studio Code. So in fact, today I'm going to use Visual Studio Code to edit our project on Glitch as opposed to the in-browser editor. I just think that'll be a fun thing to try out, and you can all follow along just as you normally do. Instead, like I said, right now I have this project prepared and I want to walk everyone through it, but instead of walking everyone through it here, you can see the project is called Puffy Denim. I don't know if you can see that. Maybe it's a little hard to see. But we're going to switch over to Visual Studio Code and connect to this project there and do our editing there. I have VS Code open along with a dozen other things. So I actually have the the glitch plugin installed here, but you can see it is the glitch extension, and it lets you, like I said, connect to all kinds of stuff. And the way you use the glitch extension is you actually interact with it through the command palette, the same way you'd interact with a bunch of other stuff. So if I open up the command palette here, you can see right here I've recently used some stuff, and one of which is glitch open project. So we are going to hit open project. It's going to hit the API, and it's going to return a list of all of my glitch projects that I can search through. And you can see the second project here, Puffy Denim, is the project we're going to be playing with today. I'll drop a link to that in the chat. But if I click on this, it's going to actually reload the VS Code editor, and you'll actually see that now, instead of the normal UI, forgive the saw noise in the background. I think my neighbors are getting a new roof. Wonderful, wonderful. We can jump into the project, and you'll actually see it is the Puffy Denim project from Glitch. Over here, you can see the file tree, and then over here, you can see the file tree. And so I can actually open up this project and really quickly just pull these two things side by side because I think this is really impressive. We'll go to the index file over here. We'll go to the index file over here. And if you can see this, bump up my font size so you can see both bits of files. I can actually go in here and say PixiJS particle demo. And it's actually updating over here on the right, and the page is auto reloading. So we're actually going to use that today to do a little bit of live coding. We're going to live code using VS Code, because I think that'll be fun. You can see all the nice things you get from VS Code. Down here, I can get the project info, see how many people are connected to it, stats, all kinds of stuff like that. This is a really cool thing, I think, for people who really like using a dedicated editor. The VS Code extension will make a big difference. So yeah, if you are curious, you can check this out. Oh, I dropped the wrong link in the chat. Let me see, there we go. That's the right link in the chat to play with the extension, install it, and use Glitch via VS Code. Today, like I said, I'm going to actually let us pop our particle demo into a new window. And I'll tear that off, and I will actually just minimize our glitch browser window and put these two things side by side. It says extensions have been modified on disk. So we're just going to reload the editor real quick, reconnect to glitch, and we are off to the races. I'm actually going to now jump into this code and show you what the heck is going on, as opposed to talking about the meta. We have an HTML file. And on the HTML file, no, that's not what I want. On the HTML file, we have bump font size up. We've got, I'm pulling in Pixi. I'm pulling in Pixi Legacy, which is a library that lets us do some effects that otherwise Pixi can't seem to do. I'm not sure 100% why we did the legacy library, but in all the examples I've seen, they use that as well as Pixi. And I did find that some of the effects didn't work without it. So we're just going to do what all the cool kids do and pull that in. And then we have our script, which is what we control. I'm going to clean this up. I don't need the p tag. And so all of our logic lives over here in script.js. I'm going to hide the mini map, just it's taking up a little bit of space we can put code in. Cool. So we have our this file that I've pre-prepared. I made a project prepared this week. Like I said, it is called Puffy Denim. So you can click and take a look at the project here. And if you'd like to actually view the source of that project, I will drop a link to the source as well. Cool, so there's a link to the source. And I'll throw that into our on-screen as well. So here we are. Here's our particle demo. There are no particles. But so I'm going to create a stage. I've defined that to be 640 by 480. I have a what I call texture canvas. So I want to define the shape that I'm using to make my particle effects. This is use as the particle texture. And you actually can't see that, but that is on the page. It's just a white square, so there's nothing to see. So you can see I create this canvas. It's small, it's 16 pixels wide. I'm drawing a rectangle within it. And then I create my Pixi thing and mount it. I'm creating a particle container, which is a specific container that is designed to handle a certain quantity of these small particles. And I'm turning on a bunch of different options. Their positions will change, their rotations will change, UVs, which is remapping the texture, tint, I can change the color of the particles if I want, and the alpha. So I want to change the transparency of them if I so choose. And I'm adding that sprite container to the page. I'm creating an array to hold these sprites. This is just a quick thing that if for some reason you can't get the WebGL renderer up, we can reduce the number of sprites. And then right here is where we create a sprite, we create it, map it from the texture, and then anchor the texture to the center of the position. So I want my sprites to be centered. Then we can set a bunch of stuff up, which is where we can set a bunch of initial conditions for our sprites. And then we can push them onto the array so they can be accessed later, and we'll add them to our particle container. Down here, we have sort of a tick, which is just it's time. That's the best way to describe this is it's time. Some sort of time for the life of the particles. And I have a bounding box. And then lastly, down here, we have this array where we can update our particles. And so we can also keep track of time. All right, so really, we're creating a bunch of things, we're adding them to our scene, and we're updating them. It's not really that complicated. The nice part is that all of the actual drawing it to the screen is being handled by Pixi. So let's say right now, I don't know if you can see this, but way up in this corner, we have this little, those are all of our particles right now, are just clumped in the corner and not moving. I think let's start, just because it'll be easy, we'll start with doing, I think, a snow particle effect. We already have white rectangles. I feel like that's a good portion of the way to being snow. So we're going to say particle.x equals math.random. I can type today. Oh my goodness. Times width. So it's going to be hard to see the difference, but by default, there's now a bunch of particles scattered across the top. And we'll say particle.y equals math.random times, I don't know, 20 minus 20. So I want to hide these particles off the top of the screen by default. So you'll see that happening, which then you can't see them anymore. And then let's add some speed. Let's say particle dot, say dy or vy, maybe for y velocity. And we'll say math.random times, oh, I don't know, 0.5 plus 0.2. 1. So we want them to all of them to have a vertical velocity, but they move at different speeds. Okay, so now we have a bunch of particles. They have downward speeds. So let's go down here and figure out how to update them. We're going to do ticker tape. Oh, that'd be a lot of fun. I like that idea, John Nicholas. Let's definitely do a ticker tape parade. So let's say particle.y plus equals particle dot plus d equals dy. And when this reloads, what we should see, oh, I said vy, not dy. Sorry, vertical velocity. Okay, so they're falling way slower than I meant them to. So let's turn these up, 0.2 plus 0.5, let's say, to increase the range of our speeds. And here we go, we have snow. One of the things that I want to highlight is, I still need to figure out what's going on here, but OBS does not get along nicely with my graphics card. And so what you're seeing is going to be a little bit chunkier than it would otherwise be, just because OBS is capturing the screen and that has an effect. I want to do something about that in the future. Right now, our snow has fallen off the screen, which is all well and good, but I want more snow. So let us check to see if particle.y is greater than height plus, I don't know, 4. So if it's fully off the screen, let's reset it. And then let's increase the speed just to make sure this effect is. I know the snow's gonna be falling really fast, but maybe it's really coming down. Oh, and I said less than, I meant to do right greater than, and let's say -10. So we're resetting our particle. Yeah, peek right down. This is like old school, super basic, like snow effects. I absolutely did this with QBasic back in the day. I didn't even make it so the snow accumulated and made piles. It's the best. Oh no, I mean, the old is shared. But here's our snow. Of course, we can turn up the amount of snow, but by cranking up the amount of particles. So we can see right now we're sort of getting this. Oh, there we go. After a moment, it kind of stabilizes. First, we get a little bit of snow dropping, and then it kind of continues. So because we're not constantly regenerating the snow, we're just waiting for it to reset. It's all falling in the same position. So we can say x equals, let's reset the x every time let's reset the x so every time it goes off the bottom of the screen, it starts at a new position. Okay, I would argue this is an extremely, and I'm pasticle, which is a small particle of pasta. All right, so now we have snow. I think snow is probably one of the simpler things we could do here. Also, they're just squares. I feel like we can do a lot more stuff with this. One of the things we could do is make our texture a different shape. Let's make it a circle instead of a rectangle. You'll have to indulge me a moment while I go look up. I think it's ellipse. How you do a circle in Canvas. Sure is, and so we're going to center that. Cool. Start angle, end angle. Okay, so it's ellipse, and then you use a radius. Great. So now we can go back into our editor and draw an ellipse instead. And we'll say texture context dot begin path, and then we'll say ellipse, and let's say, so this will be half, our thing is 8 is 16 by 16, so we'll say 8, 8. We'll give it a radius of, I don't know, 4. It's for our radius x or radius y. I really should have left those docs up because I never knew what the other things were. Rotation, start angle, end angle. Okay, so rotation, because we're drawing an ellipse, it doesn't have to be flat, but ours will be. So we'll say 0, and then for our start angle and end angle, we'll say, honestly, I'm just going to, I know I could say math.pi times 2, but. And then we'll fill it with our fill color. And now, instead of fabulous, now our particles are all circles as opposed to squares. They're still the same size. So one of the things I can do is go in here and say scale true. And that will actually let me, now I've turned in the particle container, I've turned on the ability to scale our particles. And so we can actually say, we'll say particle.scale.x, and I'll set these to be the same thing. Particle scale.y, and we'll say math.random times, let's say, math.random plus 0.5, which means it'll go from 0.5 to 1.5. And so now we can see that our particles have different sizes, which I think is pretty great. Can we change them to pasta? We absolutely could. One of the things you can do is use a graphic here as opposed to a canvas simple shape. So I could pull in a graphic of a pasta and snowy with a chance of meatballs. Okay, you know what? Let's do snowy with a chance of meatballs. I like that idea. Okay, so if we've got a meatball, let's see. So I'm going to do a couple things, because I think now we're getting into a couple situations where we do want to occasionally reset a particle. And if we reset a particle, we're probably going to be repeating a bunch of this logic. So I'm going to do, make a function called reset particle. And this is going to be, and it'll take a particle, and then that will let us reset a particle back to its initial state and do all kinds of stuff. I'm also going to do another function just as a helper. We're going to do const rand, and that's going to be min max. And that will be math.random times max minus min plus min, and that will give us a really fast way of making random values. So we now have this function called reset particle, which now we can do things like this. We can say, let's roll the dice, and let's say if math.random is greater than, let's say, less than 0.1. So 1/10 of the time, instead of a snowflake, we're going to have a meatball. I think that'll be fun. And I'm actually going to spawn this demo as a non-auto reloading demo, just so we can hit refresh when we care. There, so I just broke off the window and did our own thing. Ooh, my VS Code take a nap. The joys of beta software. We'll just reopen that. We have a little bit of an infinite loop with the VS Code thing. We'll have to take a look and figure out what's going on there. I'll submit that as a bug. So we're going to say that with a 0.1% chance, or a 1/10 of the time, actually, let's make it even rarer. Let's make it 1% of the time. So if math.random is less than 0.1, we have a meatball. Because that's going to let me show off a couple things. So I think the first thing that's going to happen with the meatball is going to be big, right? So meatball will be 3. It's going to be a big meatball, right? Else, snow. And then we can copy our snowflake logic down here. And we can say reset particle. And then in our snowflake logic, we have the ability. So we have snowflake logic, and then, so that's normal. We want to initialize our snowflakes. I want to initialize the position, the starting position of our snowflakes the same no matter what, but we want to set up our initial position for our objects no matter what. We want to, but if our particle is a meatball, we want to go fast. So this is going to be plus 5. So meatballs are going to go by quick. I also want meatballs to be not white, but let's see what happens right now. Right now we've got particles with a chance of meatballs effect. Oh, last thing I want to do is if our particle is off the edge of the bottom of the screen, we can say reset particle, and then we don't have to worry. Now we can automatically reset particles when they drop off the screen. So now we've got snowy with a chance of meatballs. Right now our meatballs, I don't know. If we have meatballs, they're not falling very quickly. I can't really tell. I think we might, but I don't feel like they're moving very quickly. So let's see what's going on here. Oh, right. We also made this rand function, which means we can now start saying and -10, -30, -10, and this can be, let's say 8, 10. This is nice. I like this. Is much faster, much shorter code. So 0.5, 1.5, and then lastly, rand 1.5. Cool. So I've just rewritten that to be, you can also see the meatballs are presently white. That's the one thing. So we're going to change that. This is where the tint effect that I talked about earlier comes in. We can now say particle.tint, and let's just say OX CC0000. So that's like a bright red tint for our meatball. I'm not sure why our meatballs are red, but they're going to be red. And we want to reset our tint just on the off chance. And the way you reset tint in Pixi is you say, and this is interesting, Pixi has you specify colors using actual hex numbers, which I thought was pretty interesting. So now let's see, do we have meatballs? Yes, we do. Not often, but every once in a while, as opposed to a snowflake, we're going to get a meatball. I think they should fall even faster. Let's say 15 to 20. Because I think a meatball should not hang around that long. There we go. There's meatball. Great. So we made snowy with a chance of meatballs. And so this is, I would say, a deeply silly example. However, this shows off a bunch of the fundamentals of particle effects. Creating sort of a supply of particles, some quantity that's usually fixed or capped, updating them, and then when they've reached the end of their life, in this case, or the end of their effect, either resetting them to respawn them from the beginning, or usually the other thing you can do is just hide them. So let's say it's like a firework, right? At the end, you don't set the firework off again. You just stop it. So one of the things we can do here, so let's do something a little different this time. I think this is Snowy with a Chance of Meatballs is a lovely example of one way to do this. But what if instead we did, let's try a basic firework, because I think fireworks are very cool. So we're going to do just a simple starburst. We're going to have all of the points start at the same place, expand outward very quickly, go bright, and then when they melt, the water cycle sends them back. When the meatballs melt or the snow. So now we're going to do a firework as opposed to our previous effect. So we're going to rewrite some other stuff, but I think this will actually be really cool. Maybe we can even save this. In fact, I am going to save this, but the way I'm going to save it is just let it be held up in the rewind status. Or should we remix? Maybe we should remix. Can we remix from here? I actually haven't tried. Remix current project. Cool. So we're going to take Puffy Denim, and we're going to remix Puffy Denim and actually create another project called Golden Pigeon. Which is going to be, instead of Snowy with a Chance of Meatballs, our firework effect. So I'm going to throw this into the channel. And now we're going from Snowy with a Chance of Meatballs to Golden Pigeon. And the Golden Pigeon is going to be our fireworks. Same particles, let's say we've got 200, and we're going to do something a little different. So our particles are going to start in the center of the screen, and so we're going to say width over 2. Just going to start from the center of the screen first. Height over 2. We no longer want random meatballs, so we're going to clean up the random logic here. But we are going to have some other random numbers filled in. I think scale, I'm actually going to keep scale the way it is. Maybe I'll do 0.8 to 1.2. I want the sizes just to vary a little bit. The tint, we're actually going to vary over the course of the effect. So right now, I think they'll start, I want them to start actually, just going to leave them untinted, so we'll just remove that. And instead of setting a velocity x and a velocity y, what I want to say is particle.speed. We can send a random value from, I don't know, let's say 10 to 12. And then we'll have a different random angle, right? Because it's the fireworks. The things are going to shoot out in different angles. We're going to say particle.angle equals rand. And that's going to go from 0 to 2 times math.pi. So we get a random angle random speed. And I'm going to set one more thing, and that's going to say particle dot, oh, how best to describe this? I'm going to say particle dot life. And particle dot life is going to be rand times, I don't know, 20 to 25. And this is actually going to be how long does a particle last? When a firework goes off, not everything doesn't go out exactly at the same time. And so I want to actually quantify that in here by determining determine sort of the lifetime of the particle. So this is going to look a little janky at first because I think we probably have an error on the page. But I'm also not terribly concerned because we haven't actually done anything. Oh, here we go. Here are all our particles stacked in the center of the screen. One white dot. And so there are a bunch of different things we want to do with particles. But all of those things, when we're doing a, this is one of the things where this gets kind of weird, right? We're actually going to vary things over time, right? A firework is bright and then fades out. And actually it starts off not bright, goes bright really quickly, and then fades out. So how do we do that over time? I'm actually going to create some linear interpolation functions to help with this. So we've got a function called, sometimes you call this lerp, which I think is funny. Min, max, I, or sometimes written as A, B, I. And what linear interpolation lets me say is I want to go from value A to value B over the course of 0 to 1, and I is that number 0 to 1, and it's like a slider. It's a computerized slider, maybe is the best way of describing this. So it's going to look a lot similar to our rand function, actually, but it'll be, instead of a math.random over a range, it will be I times B minus A plus A. So that's a function that lets us very quickly vary between two values. Ricardel, technically it starts not bright for the first like millisecond, right? If you see a firework go up right when I guess maybe it starts bright. So maybe I'm wrong. Maybe it starts bright. Let's find out. I ultimately want to make potentially a gradient function, but right now we'll start with just this linear interpolation. And what we're going to do is you can see that we've got this function and we've got this life. So now we can go down here, and the first thing we're going to do is we're going to calculate where, we're going to say let I, I'm just going to compute I, or I've already have I, but let's call it maybe t. So t is time, and t is going to represent from 0 to 1 how far we are through the life of our particle. The first thing we do is we take tick, which is the time of our particle effect, and we're going to divide that by how far we are through the particle's life, so particle.life. So as opposed to doing these things on a physics or on a constant basis, we're going to compute everything over the course of an effect. So what that means is particle.x equals width over 2, it's going to start in the center, plus we've computed its speed, I believe. So it's going to be speed times math.cosine of particle.angle. So this is, I'm going to actually break this up into, just because I think it'll be nice to see the different components here. And so this determines how fast it's going, and then actually we're going to multiply that times lerp. Oh, actually we can do it this way. It's going to be math.cosine times lerp, and we're going to go 0, 1, or 0, I don't know, 10, the size of our firework, and t. And this looks like this. So if this worked, just on the x-axis, you're going to see our firework kind of go poof. It did work, but it's happening very slowly. I don't know if you can see that. It's spreading out, but unbelievably slowly. So this did work. I think these need to have a much shorter life. So maybe we'll say 1 to 5 right now, just temporarily. So we can see the effect go faster. This is kind of like a slow motion firework, but we'll allow it. Okay, so we can also, so maybe we will also compute y, and y will be computed as math.sine of particle.angle. And we now have this repeated number, this 0 to 10 over t. I'm going to actually take that out of both places and copy it and replace it with what I'm going to call distance, because that's going to be the linear interpolation over the distance from the center. And so we'll say let distance equals, compute that number just once. And now we'll take a look. Okay, still looks like a firework in slow motion, I think. But it does kind of look like a firework. Maybe, like I said, a slow motion firework, but a firework. We can speed this up by reducing the life of our particles even further. So let's say 0.51 and try this again. So we've now got this firework. In my opinion, it's still going a little slow, but that's okay. But I think that kind of looks like a firework. Oh, except for one thing, it doesn't fade out. So I want to actually make this also fade out, right? So let's say particle.alpha equals, I'm going to say if t is greater than 0.8, right? We could actually take a little bit of the time here. We can say if t is greater than 0.8, then particle.alpha equals, and we'll say, so that gives us 0.2 of our time. Could I add gravity to this system? Absolutely, I could add gravity with this system. One of the things we could do is keep track of the vertical velocity and add a little bit of stuff like that. You know, we'd have to mostly keep track of the individual components of our velocity to do that, but we kind of did that with snow. Snow was effectively a gravity effect. But if we wanted our firework to go out and then kind of fold down, or like, I kind of think confetti would be cool that way, right? It's kind of poof and then down. We'll definitely do something with gravity. So we can say particle.alpha, and we'll say lerp from 1 to 0, and we know that it's only at the last little bit of our time. So we can say t times, this is doing some math here, right? The last 0.2 of our t, super confusing. So the last 0.2 of our time is going to be, so it's going to be times 5. So 0.2 times 5 is 0.1, but we're also doing, so it's actually t minus 0.8, right? And then the other thing I want to do is actually cap the time. So we're going to say min, and we're going to say these end at 1, right? There's no more to do once they've reached 1. So let's refresh. And assuming I did it right, that didn't last very long at all, did it? So I think our time does need to be longer. Let's say, ooh, did I get stuck again? Perhaps I got stuck again. Confetti, I think, would be a cool end goal, John Nicholas. To sort of take the snow, take a particle and make it a bunch of different colors and make it poof out and then fall down. I think that's like my end goal. So we can control, we want these particles to have a longer life. So let's say 10 to, I don't know, maybe back to 10 to 20. And maybe I need to up the speed of them. So let's say speed will be 30 to 50. Am I currently taking advantage of speed? I'm not taking advantage of speed. That's what's missing. No wonder these all kind of go the same way. I knew I was missing something. They now have speed, but their life is actually not too long. Adjusting these parameters is really, I think, a big part of it. So we're going to do 7 to 8. And maybe I actually want to tie the life to a time in seconds. We can absolutely do that. And maybe I may even do that going forward. They faded out just as they reached the end of the screen. So we're going to say 4 to 5 is their life. That did not seem to make a tremendous quantity of difference, did it? We're going to do a slightly different thing. Right now we're using a ticker to keep track of time. I'm actually going to say let start and say date.now, and we're going to do a time-based version of this. So this is going to be, instead of incrementing the ticker, we can say let now equals date.now. Let elapsed equals now minus start. And that way we can keep track of the life of our particles over a time thing, and that way you can reason about them perfectly, right? Well, you can say, as opposed to tick particle life, we can actually say elapsed. And so this is going to be in milliseconds. So let's say we want our particles to last for between 500 and 600 milliseconds. We can now totally do that. So let's take a look. Try that again. Obviously things got, kind of goes by really quickly, which means I probably could stand to make that maybe give them a longer life or what have you. But I feel like we're now in good shape. Speed, and then I think I have a random multiplier. I do. So actually we're going to call this just speed. Let's take our magic numbers and put them all in one place. It's a very, very, very small thing. Let's do one more thing. I think this will be fun. Now we can say, I'm going to say app.view, which is the reference to our element. We can say add event listener, click. And so if we ever click on our canvas, let's reset our time. This means we can check the effect out more than once. Bye, Cardell. Thanks for hanging out. But now if I click, I need to do one more thing, which is if, let's know the other issue, is this should say particle.alpha equals 1 to make sure that these are full otherwise. Okay, here's our firework. I'm not going to sit here and tell you that this looks the most like a firework of all time, but it's not terrible. So let's go in and make it look more like a firework. First thing, more things will stay toward the center because a firework is really more of a sphere. So one of the things we can do is actually make this go from 0, and then let's make it go to 100. And then also fireworks have more of a trail off. So we're going to make this go to 800 milliseconds. And we'll refresh. Ooh, I think that's starting to look good. And the last thing I want to do is actually change the scale over time. So I'm going to say particle.scale.x equals particle.scale.y and set both of those equal to lerp. And let's say we're going to set this actually to be size. Because then we can say particle.scale.x particle scale y. And we can set that to be scale times. I know I'm doing this double assignment thing in a couple places. I know it's a little confusing, but it's maybe I'll in fact fix that. So A, it stops wrapping, and B, it there we go. So and then these two will be say 1 to 3 T. 1 to 3 T. So now we've got scaling. And this is not particle scale, it's particle size. So we're going to update all of these properties on all of our particles. kind of gets a weird bokeh effect. So maybe we actually want to do 1 to 0.5. I don't hate it, but also I don't love it. Or maybe even 0.5 to 1. Let's do that. That way our texture also isn't getting stretched necessarily. Okay. Check that out. There's our particle effect. The next thing I want to do is potentially let these particle effects happen in different places. Right now I just have it centered on the screen. Also, I think I want them to be able to potentially have a color. That can be cool too. The way we can do that right now is I can say particle.tint. Let's make our fireworks cyan. Let's just see if that works. So we're going to do 00 FF and make some cyan fireworks. Some like bright blue. See if that works. Yeah, totally. Okay. So we now have the idea of fireworks. Maybe we can even change the color randomly. Let's say every time I click, let's say tint equals, let's set them by default to be just whatever they are. We can say tint equals tint. And then every time we click, we can say if, I don't know, let's pick some random numbers. Let's pick a different tint. So tint equals red. Let's just do this, all the fun ones. That could be something I'm doing. So I just want to just make sure that for the purposes of the stream, we're not sitting around waiting for the editor to unfreeze. I may have a nasty plugin installed that's misbehaving. In fact, I'm certain of it. So we've got colors so we can make our firework. Let's pick some other ones. I'm just going to do all the classics. Great, and that's 5 different fireworks. Oh, we'll do classic white as well. And we'll pick these at random, so we'll say math dot. We'll floor that number. Great, now we have a random tint for our fireworks every time we make one. Red, green, yellow, green, violet. Oh, yeah, take a look at that. There we go. And I have violet twice, which is why it's appearing twice. Just gonna turn off auto refresh. But now we've got our little fireworks demo. Boom, boom, boom. I love it. I love it a lot. So now we have fireworks. We could make them go in different places. We can do all kinds of stuff. Places would be pretty basic, but effectively we'd be able to say when I clicked, fireworks go off wherever I click. So we could totally do that, right? We could say let cx equals width over 2, let cy equals height over 2, and then here where we've got our width over 2 and height over 2, we say cx cy, and then when we click, we can actually grab the event location. So we'll say cx equals e.pagex minus app.view.offset left, which by the way is a way to get the local position within a dereference there. So when we click, variable mistake, but when we click, we'll actually be recentering our particle effect. I think that is awesome. What's interesting, I don't know if you can see this, it's very subtle, actually really subtle. But every time we click, the firework goes exactly the same. And that is because I'm not resetting the particles between each effect. We totally can, however. So one of the things we can do is say, right? So when we click, we want to reset every particle. And now when we click, the fireworks will be a little different. It's subtle because it's very small. One other thing I want to do with a firework is when a firework first explodes, it's not its color. It's white because the intensity of the effect. It's so white and then it becomes the color as it spreads. So we already have a concept of this where we have this idea where if something is greater than a certain amount, we linear interpolate it. So let's abstract that into a function, right? And so I'm going to call this function. And it's going to be kind of a confusing. I think I'm going to use the term gradient. I know it's a little confusing, but in this case, I'm referring to any multi-part linear interpolation. And so when you call a gradient function, you're going to pass the gradient, and you're going to pass I. And we're going to define a gradient, a set of steps. So a set of like from 0 to 1 stops. Think of this exactly like a color gradient. In fact, one of the things we can do is a color gradient. So for instance, this will be const gradient equals grad I. And what the gradient function is going to do is it's going to say for let stop equals 0, stop is less than stops.length, stop plus plus. We're going to go through our stops, our color stops. We're going to go through the stops of the gradient, and the first thing. So let's make a sample one so this actually makes sense. Let's say we have this idea right now that we want to go from 1 to 0 after we go past 0.8. So what I'm going to do is I'm going to say let brightness. And we'll make this will be our first gradient. And the way we're going to write this is I'm going to do the first position, which is going to be 1. And then, so the first number is going to be the position, and the second number is going to be the value. So this is a gradient. This is the gradient of our brightness, actually. So yeah, 1, 0. So from 0 to 0.8, it stays the same. And then from 0.8 to 1, it drops to 0. So that is going to be what our brightness gradient looks like. And so you can see if we say if for everything in the gradient, we say is I less than or equal to, what do I want to do? Yeah, let's say if I is less than grad stop 0. Right, we want to find the gradient that it's between. We want to find two. So if it's 0.5, it's between 0 and 0.1. So actually what we should do let A B. So if I is, let's say, greater than or equal to, yeah, this will be okay. If grad stop 0 and I is less than or equal to grad stop plus 1. That's the way to do this. I'm trying to go through and find these two values. Maybe I'll say A equals, let's do this. A equals grad stop 1. Yeah, let's do it this way. B is equal to grad stop plus 1, 1. And then if I is greater than grad stop 0, we break. Because we're done. We found the first one it's inside of. And then what we can do is we can return lerp, the linear interpolation between A and B, but I is not going. It's actually going to be I minus. Ooh, yeah, okay. So these are actually going to be the stops. So it's actually going to be like that, and then stop. Grad stop 0, which you actually have a reference to. It's just A. So, because we're going in increasing order, we'll stop at the first bucket we're in. And so we're going to go between A1 and B1. And I is going to be minus A0. And that's going to be out of. So it's I minus A0. And that's going to be divided by B0 minus A0. I know it's a lot of like nasty math, but effectively what we've written is a function that lets us really quickly cycle through and find the next, or compute a gradient. So let's test it. We have this brightness gradient here, which is actually our alpha. But we can, instead of this whole piece of logic, we can now say particle.alpha equals gradient brightness T. And that's going to compute the brightness of our gradient. Let's take a look. As we can see, it didn't. So let's figure out what's going on. It just, everything sticks to the edge. I don't know if you can see that. Which means this code did not work. We can test. We actually have it in the page. I'm going to bump up my console. So let's take a look. We have a function called gradient. And we'll pass it 0. And immediately I see an issue. Apparently the value of gradient brightness at 0 is 5. Let's take a look at our code to see what I did wrong here. We're temporarily, this is going to seem a little strange, but we're temporarily going to just bail. We're just going to not do this temporarily. So let's see what's going on. So we can do a little bit of log debugging. No firework for you. What that means is that I can write a little story. I do this sometime. In our range stopping. So sometimes when I'm trying to debug something and trying to understand what's going on, what I do is I write a short story. So I'm going to say, which is like exactly what it sounds like, but I say console.log, here we go, here's my short story. A, B, checking out in our range stopping. And now we can rerun this piece of code and not log a million times. Here we go. So it's checking out from 0 to 1, 0 to 0.1. And look, it never broke. Do you see that? It never broke. Aha! And it's because this was not greater than or equal. So I'm going to refresh this again. And, okay. Now, check it out. Here we go. It's checking out 0 to 1, point at 1, and it determined it's in its range, so we're done. Okay. That's exciting. Remove all these logs because we don't want to log for every frame for every particle. That will crush us. And uncomment this because I think we debugged. Let's take a look. Well, it seemed like maybe we had. Let's keep taking a look. What's the brightness? It's 1. It says it's 1. That is also wrong. Maybe I was a little quick. Let's say 0.9, 1, 0.8, 1, 2, 1. Okay, So what else is going on here? Let's read this. I think I see the issue potentially here also. No, that shouldn't matter. This should always break as long as the end is, well, back into debugging. Undo, 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 undo. That's okay. So, in our range, stopping. Something is definitely amiss. Here we go, checking out 0 to 1 to 0.81. And actually I want to see, because really the question is, are we between these two values? So I'm going to log all three of those values. And we'll try that again. My logic is bad. So what I actually want to do is less than B0, maybe. Let's try that. Maybe I have my logic wrong. -5. Well, 0. 0.5, 1, 0, 1. You know what? There we go. This is one of those functions that I've actually written a couple times before, and I feel like I should just include in like a library because it's really, really useful to be able to, hey, look at that. So now we actually have the effect. This means we can do all kinds of things. Okay, so this is where this gets cool, in my opinion. So I'm going to move this down here, just with the, I want to define a couple of these in a place. So let brightness, let tint gradient. Now I'm going to rename this to be brightness gradient. Because now I can say 0. Right? And then very quickly go to our actual tint, which will be that value. And then at the end, we'll stay at that value. Right? So this is what it looks like at first. But what I actually want to then do is make these two values tint. Now, I'm not 100% certain what this is going to look like, but I am excited to find out. So let's try it. Oh, I need to actually use this information. So cool. So now I can see what the tint gradient looks like. And it does not look like it's doing anything to speak of. Make sure I've refreshed. Let's try something a little different. Let's just do the first two. Whoa! That was not what I was anticipating. I don't know if you saw that. I'm going to zoom in. So first, white looks normal, but look what all the other ones look like. Did you see that? That is not what I was going for, but I really like that. Yellow looks pretty normal, but some of them really look out there. Oh, I could do that. I could do that forever. Okay. And I actually do understand what's going on here. What's going on here is that these are just numbers. And so it's running, if it's a low number, it just runs like if it's, you know, this or this, it has to run through all the numbers to get to it. We go from FFF to that, which means it's cycling through like every color in the rainbow. But gosh darn it if that's not cool. That's cool. I really like this. Is it exactly what we wanted in the world? No. Does it have a bunch of useful functions that will let us do all kinds of other stuff? Yes. Another thing that just, maybe we do one more thing to this, which right now you can see that like this just linearly expands, which is not exactly what these would do, right? Really what would happen is they, like, this is like, in reality, like a firework kind of expands very quickly and then slows down. We have the ability to get around that. There's sort of different functions you can use, right, to ease between one and the other. What is it? I think math.square root is one of the good ones, right? So we're going to do one of my favorite, take one of our favorite moments and pull out grapher. And take a look at a couple different easing functions and some easy ways to write easing functions. So we're going to pan in because what we really care about is from 0 to 1 here, right? So as axes, there we go. So from 0 to 1, right? This is a linear thing. But what if we did, you'll see why this looks interesting. What if we did the square root? I can zoom up the screen a little bit so you can see what's going on here. Now you can see what actually happens is, what's actually going on here is like so at 0.5 on a linear, we're already almost at 0.75. So this is actually kind of an ease out effect. But a square root, what is a square root actually? A square root is actually x to the 0.5 or x to the half. So what if we wanted to do a different easing function? We totally could. We could do x to the 1/10. And now we're taking the 10th root of our function. And now you can see that's really steep. Maybe that's even too steep. But what about the third root, or the cube root? What if we took the cube root of our function, and now we have this really nice ease out? So let's try that. Let me unzoom, unmath. And so we've got our t, but I also want an eased t. And that's going to be, maybe I'll do it like this. That's going to do math dot power, and that's going to be t to the 1/3. And so for distance, what if we did eased t as opposed to our initial? Let's refresh and take a look, shall we? And maybe that might even be hard to see. So what I'm going to do is say to the 10th. And you'll see that actually now it explodes so quickly you don't even see the first couple frames. It's already exploded. It's happening very, very quickly. So let's go back down to 1/3. Now you have to be careful when you're computing a power. Powers are what's what I'm looking for? They're very expensive to compute. But I feel like this more realistically shows what a firework would look like. So I'm kind of pleased with this. And I actually think we have a lot of really useful functions for particle effects in here. So maybe we can collect the useful functions together. In fact, I may even make a new file. Oh heck. Particles.js. So we're going to make a file called particles.js because I actually want to abstract some of this stuff. because I think these functions are useful enough that they should live in their own file. All right, we could write this as an ES6 module. Right now I'm just writing it as globals. That's okay. There were some other things. There are other things I wanted to pull in that are valuable here. I think those are the really... Ultimately, we probably want to do one for color, for like changing color and stuff like that. But let's leave this. And then we'll just pull this file in. But I think it's really nice to see have those abstracted to their own file, because hopefully I may actually use those functions again sometime. I think they're valuable. But yeah, we sort of have these, and I'm going to do a bit more abstraction while we're in here. Did I move right? Oh, I need to... You know what? I may actually write this as a ES6 module, given that I need to import these things anyway. Let's do it. Export. Ta-da, it's a module. And then we'll have to rewrite our index. So we'll leave PixiMin and Pixi Legacy. We don't need to include this anymore, but we do need to say script and then we can pull in script.js, and then we can say const, or I guess we'll say import rand lerp. I think those are the ones we used from /JS. And then we're going to do one more thing. Well, first let's make sure this is working. Totally is. Okay. So we have a couple different things in here that we can just, I think, clean up. But we now have this idea of initializing our particle effect, right? So that's what, so we have this, which is creating our particles. We have this, which is resetting our particles. But we also have this function called reset effect, which right now is attached to click. But it doesn't have to be. And so what we can actually do is take out, I'm going to leave the event handler, because I actually want the event handler. But we now have this idea of an effect, which resets all of the particles and resets our clock and picks a new tint and picks a new gradient. And then we don't need these anymore, because as opposed to initializing these values twice, maybe we, in this case, we do want to take X and Y from a parameter, right? We want to reset our effect. Oh, and I see right now these things are not attached to anything. I wonder if we can just attach these to our particle. We have this particle container. So let's take a look at the docs for particle container. I'm trying to chunk this stuff up into a nice, easy to reuse and understand way. So we're going to say particle container, pixi.particle container. Cool, there it is. There are also X and Y. If there's position, there is. Great. So we were using a variable. We were using the variable cx and cy to set the position of our effect. But why do that? We don't have to do that. We can actually reposition the effect. So X and Y are actually sprites. And I'm actually going to rename that to effect probably. But sprites.x equals x. Y equals y. What other kind of properties did this have that we could read from? So let's hang some other stuff on it as well. So we have this thing called, and we're gonna hang on, it's got a couple references all over our files. We're just gonna effect. I know sometimes that was the word. That's okay. What can we do with a Pixi container? I'm looking to see if there's like a special place I can hang data. So we can say effect.start. So these are going to be global properties on our effect. I actually don't know that we're using this bounding box. We're just going to throw it away. We no longer need these two values. And now we're cooking. Okay. There we go. Here's our brightness gradient back. And now we can say reset oh, and we'll need to recalculate that, so e dot. And by default, these will be the defaults. So the last thing we'll do in this file is do our first effect. Ah. Oh, this is cool. We no longer have to sum this in because we're positioning the entire effect. I think that's cool. Any errors? No, but also no effect. What did we mess up? Ah, everything is set to nan. Because same here. Did we do it? Did we do it by the end of the song? Did we refactor? All right. How was that for a refactor? That was a powerful one. Hopefully this file is a lot easier to read now for folks, just because things are being calculated nicely, I want to say. We could even potentially make this a little bit more polished, but I feel like this is pretty good. Obviously, like I said, these don't have to be little circles. These can be any shape. These can be an image. Maybe it may even make sense to make this, to temporarily show this off with an image. So let's go find ourselves a little image, shall we? I think that would be valuable. Let's use stars. Let's find a 5-pointed star. Into the internet. I need to provide credit, so we will definitely do that. But first, let's pull this into our project. The way I'm going to do that is actually just wget it into my project. Then we'll rename it 200px. Let's name it star.png. I renamed it to start.png. Did it again. There we go. And re-update the UI. And while that's re-updating to pull in the star, let's take a look. Obviously, this README is not any of these things. So we're just going to quickly say pixi.js particle demo, and just at the bottom make sure star graphic is from Just want to, this is us being a good citizen. So right now we have this, what is it? Where is it showing it? It is, right now we're pulling this thing from texture canvas. What we can do is say from image, PNG. And I'm going to assume that if we're going to be using a star, that we want these to be bigger. So I'm going to change our reset particle code and make our stars bigger. First of all, they're going to be, oh, I take that back. They're going to be huge. They're 200 pixels by default. So let's actually maybe say 0.1 to 0.2. I think these might be way too big, but I'm super curious what this is going to look like. One of the things we're noticing is that they're all facing the exact same direction, right? So let's give them a rotation. We can, of course, make the rotation and the angle be the same thing. So when the way they come out, right? That could be a cool look. We just need to make sure the star graphic loads before we go any further. So it's loaded. Weird. Some percentage of the time it works. It's like it can't load from cache. That's what it looks like. Yeah, see? That's weird. I do kind of like the look with the stars. I might make this 0.05 to 0.1 because I do want them small. And I need to figure out what to do about the cache thing. I guess one way, let's be lazy. Plus, put a cache buster on that temporarily. I'm not 100% certain why loading it from cache makes it not work. There we go. Fireworks. One thing I might change about them is, like I said, right now they're always going to be some shade of yellow because the image is yellow. Yeah, let's just do this in Page. I know how to do this, so I'm just going to do this. So image, filter, and then I'm going to make sure the page is the right size. I'm going to take a screenshot of Firefox has this concept of just selecting a single part of the page, like so, which lets me download this to a file on my computer. And then here it is. I'm wondering if it's still 200 by 200 pixels. I'm having a hard time reasoning about that. That's okay. Upload the file. Oh, it's going to put it in my assets directory. Okay, that's fine. We'll just grab it from here instead. I understand that now this is no longer, or what I'll do is, this is all just polish. We're toward the end of the stream today, so we're just gonna curl this asset and to redirect it to star.png. Great. And now if I go take a look at star.png, after modding the file system, which means I have to hit refresh. There we go. Now star.png is in black and white. And that means that we can now get our fully pretty colored effect. Oh, but it also has a white background. Hubris. Hubris, thy name is Potch. This looks really janky. All right. That's funny. Photoshop seems like overkill, so actually let's not. I'll fix the star after the stream, but I think we're in a good spot. I'm going to actually just maybe even revert the star to how it was. But you notice the limits of tinting. Tinting can't tint beyond things that it already is. Right? Tinting can't, if something's yellow, it can't make it blue because it's always going to have some yellow. It's tinted. So it can't undo the color that's in it. That's a useful thing to know when playing with these particle effects. Also, I did a bad job of curling just now. There we go. I will admit that for particles this small, using a graphic might be overkill, but it is kind of cool looking. I think it's kind of pretty. So, all right, we made fireworks. We made 2 different particle effects today. I'd love to do confetti as well. I think confetti would be the rad third one. But I'm going to go in after the stream is over and make this a grayscale star. So that's it for this week. We did 2 different things today. We played with particle effects and made snowflakes with a chance of meatballs. And then we did sort of polish that up into a firework effect. And the firework effect actually, I think, has and then we actually polished up the file to show sort of a better structure, right? We have this idea of an effect, and that can be both reset as well as its individual particles can be reset. And so that can let us do looping effects or non-looping effects. I think here's a good place to stop for the week. Thanks for watching. I had a lot of fun doing this. There was some request in chat for a confetti effect. I kind of want to leave that as an exercise to y'all, but I feel like if not, maybe we can do another stream sometime. So yeah, thank you so much for tuning in. Have a fantastic week.